Next question that we are going to do is we are going to find the kth largest. So the kth largest in this one is, let's say I want to find the third largest. So the third largest in this tree would be basically 10, because 14 is the largest number, then there's 13, and then there's 10, right? Similarly, the fifth largest would be 7, because like it's 14, 13, 10, 8, and then 7. So that is the value that we actually want to return. One way that we can do is we can actually have an array, and then we can like get all the values. So 1, 3, 4, 6, 7, 8, and stuff like that. And then we count from the end, and then we get the value. That way we actually have to traverse the entire tree, which is probably not a good idea to do that, because like let's say I mean, like the values is, let's say it's a huge tree and the value is right in the very start, in the very end. We have to traverse the entire tree for no reason at all. So instead of that, what we can do is we can take advantage of the fact that with the reverse in order, the reverse in order actually goes from the other end. So the reverse in order will actually go to 14 first, and then it'll go to 13, and then it'll go to 10. So what we'll do is we'll actually have a int store kind of a thing, where we'll keep a pointer, and we'll keep incrementing that pointer. So once we keep incrementing that pointer, what will happen is it'll actually increment that, and then whenever we reach k, and that is the point, we'll actually return the value. There might be a problem in this one. So the problem is, let's say I say that give me the 50th largest value, but there's only 10 elements in there. So in that case, I should return basically null. So what we'll do is we'll actually also have a node, um, like a node pointer value, and that initially we'll assign it as null, and then we'll put the values in there. So similar to the int store over here, let's actually create a new Java class, and we'll call this as a store ref store. Okay, so this is a ref store. We can store anything in here. So we'll say it's a template, and then we'll say public t, and we'll say value. Okay, and then we'll say private ref store, and then we'll say public ref store, which will get a value of t, and then it will say this dot value will be equal to value. Okay, so that is perfectly fine. So now the ref store actually has values. We can store anything inside it. We probably don't even need the int store anymore, but we'll keep it for now. We can change it later. Okay, so let's write the function. The function of this one would be public node find kth largest. Okay, we had done find kth largest in the searching and sorting, where we actually used quicksort kind of a thing to figure that part out. So integer k, we actually get the integer k, but this is a little bit different. Okay, so now what we need to do is we need to figure out if we'll take the base conditions. So if root is equal to null, or k is less than or k is less than 1, we'll just return null. Okay, otherwise we actually want find the kth largest. So we'll have a find kth largest. So private let's say void find kth largest, and this we'll pass a node called node, and then we need integer pointer. So we are going reverse in order, but we need a integer store kind of a thing, where we actually keep decrementing that value or incrementing that value. So we need to send the value k definitely. And then we need int store call ptr or something. And let's say we actually have store ref store for node, and this is the node that we want to assign the value. So ref store node, and we'll say node ptr or whatever. We can change the values later. Okay, so so we need to create a int store call ptr is equal to new int store with value 0. We will also create a ref store called nodes node ptr is equal to new ref store of ref store of type node, and ref store of type node, and the value that we are passing is null. Initially it is null. Okay, so that is good. And then we return node pointer dot value. Okay, so this will return the node. If the value is too big, then basically the value will return null, otherwise we'll have some pointer value. Okay, so that is good. We will call this function, and this function we'll say root, we'll pass the root, and then we'll pass k, and we'll pass ptr, which is the pointer, and the node pointer. Okay, so these are the values that we pass. So first thing we'll do is, if node is not equal to null, we are doing a reverse traversal. So we'll come over here and we'll call this function, and we'll say node dot write, comma k, comma ptr, comma node ptr. Okay, so we do our write, and then what we do is we actually have to figure out if so node pointer, so we'll say so that is the first one, so we'll actually, so it starts with 0, so it'll maybe there's some indexing problem that might happen, but we'll say ptr dot value plus plus, so we'll increment that pointer because that's the first value of the first time it comes, and then we will check if ptr dot value is equal to k. In that case, what we will do is we'll return, because we are done over here, and we will return the value, and we'll say node pointer dot value is equal to the node that we have. Okay, otherwise, so we have incremented the pointer, otherwise we'll actually go in here and we'll go to the left. And I think that should actually do the trick. So we'll say find the kth largest for the integer k. So let's actually go to the main. There might be an indexing problem, so we'll actually figure that part out. We will actually comment all of this, and then we'll copy this part. Okay. Okay, so we have this, and then we'll say node is equal to we'll say bst dot find kth largest, and let's say k value is let's say 5 would actually return us 7. So we'll put a breakpoint over here, and we'll say run, and we'll say debug. Okay, it goes all the way, does it thing. Okay, and we will go F8. When we reach over here, we can actually see the node, and the data is that it returns is 7. So basically it's just a reverse level order reversal, and we are going one back and then we are getting the value. Okay, so that is our find the kth largest. We can actually go over here and make this as kth smallest also. So let's actually write the code for this. This is just a copy and paste. Okay. Okay, so this will be kth smallest. Okay, integer k. These things will actually be fine, and we'll say smallest, and we return the value, and this will be the smallest. Okay, so kth smallest, and we'll copy this. Only thing we would have to do is dot left, and this will be right. I think that should fix our thing. So let's see what is the kth smallest. So 1 2 3 4. So let's say fourth smallest, the value should actually be 4. Okay, so we will go to our main and we will say node is find kth smallest, and k is equal to 4. Okay, so we'll run, debug this, reach over here, function f8, and the value of the node is equal to 6. 6 1 2 3 4. Okay, so the indexing in this part is basically wrong. So let's see, find the kth smallest. It's coming over here. So I think the indexing oh no, this one. So we'll go over here. I think the indexing is off by a point. So we increment the value, maybe this goes, okay, and we say run, debug. The indexing might be wrong in this, but you can figure that part out. So f8, and then the node's value is 8. Why is it 8? So 1, and then it goes to 3, then it goes to 4. So there is something wrong that is going on over here. I think the kth largest is working fine. Kth largest. So kth largest would say 3. So the third one is 10. It should come to 10. So run. Let's actually figure out if that one is working correctly. So 8. So that is 10. So that one is working correctly. We'll figure out the so you guys can actually look into the kth smallest one. Maybe that can be a homework. There's some indexing problem that is happening over there. Okay, so that will be the one for the kth largest one. Okay, thank you.